To determine the number of branch circuits required for a 120-volt single-family dwelling with 3,000 square feet, we need to follow a series of steps. Firstly, calculate the general lighting and appliance load. This is done by multiplying the square footage of the dwelling by the standard wattage allowance per square foot. The National Electrical Code, or NEC, typically specifies a minimum of 3 watts per square foot for general lighting and appliance load in residential dwellings. Therefore, we multiply 3 watts per square foot by the 3,000 square feet, resulting in 9,000 watts. Secondly, we consider the requirements for convenience outlets. The NEC specifies requirements for spacing of receptacles. These requirements are firstly, 1 outlet per 12 feet of exterior wall space, and secondly, 1 outlet per 100 square feet of floor space. These requirements ensure that occupants have convenient access to electrical power throughout the dwelling. It is important to ensure compliance with NEC requirements. Remember, this calculation provides a minimum baseline. Additional convenience outlets may be desired or required based on specific needs and local codes. To determine the number of branch circuits needed, we need to consider the rating of the branch circuits. We are assuming 15 amps branch circuits operating at 120 volts. A 15 amp circuit at 120 volts has a capacity of 1800 volt amps. Since power is measured in watts and electrical systems are often rated in volt amps, we can assume watts and volt amps are equivalent for the purpose of this calculation. Thirdly, divide the total load by the branch circuit rating. But before doing so, we must convert from amps to watts. We know that power in watts is equal to the voltage multiplied by the current in amps. Therefore, a 15 amps branch circuit at 120 volts can handle 1800 watts. To calculate the number of branch circuits, divide the total load in watts by the wattage capacity of each branch circuit. In this case, we have a total load of 9,000 watts. So we divide 9,000 watts by 1800 watts, which equals 5. This implies that we need 5 branch circuits to handle the general lighting and appliance load in the dwelling. Fourthly, we can consider the kitchen and laundry areas. The NEC requires a minimum of 220 amp small appliance branch circuits for the kitchen. These circuits are dedicated to serving countertop receptacles in the kitchen area. Additionally, the NEC requires at least 120 amps laundry circuit for the laundry area. This circuit is dedicated to serving the laundry receptacle. These dedicated circuits are in addition to the general lighting and appliance circuits. Fifthly, we can consider the bathroom. The NEC requires at least 120 amps branch circuit to supply the bathroom receptacle outlet. This circuit is dedicated to serving the bathroom receptacle outlet. This circuit can serve multiple bathrooms. Now, to determine the number of branch circuits needed, we need to add up all the circuits required. We need 5 general lighting and appliance branch circuits plus 220 amp small appliance branch circuits for the kitchen plus 120 amps laundry circuit plus 120 amps bathroom receptacle circuit. That gives us a total of 9 branch circuits. Assuming 20 amp circuits are used, it is important to note that these calculations provide a minimum number of branch circuits required. It is common practice to provide additional branch circuits to accommodate future needs or to provide greater flexibility in the use of electrical power. The NEC provides guidelines for calculating branch circuit loads and determining the number of branch circuits required for various types of occupancies. It is essential to consult the latest edition of the NEC and any applicable local codes when designing electrical systems for residential dwellings. For general lighting and appliance loads, calculating the total load based on square footage provides a baseline for determining the number of branch circuits needed. Considering the specific requirements for kitchen, laundry, and bathroom circuits ensures that adequate power is available for these areas. Therefore, a 120-volt single-family dwelling with 3,000 square feet requires a minimum of 9 branch circuits, consisting of 5 15 amps general lighting and appliance circuits, 220 amps small appliance circuits for the kitchen, 120 amps laundry circuit, and 120 amps bathroom circuit. Remember, this number represents the minimum requirements, and additional circuits may be needed depending on the specific electrical usage patterns and local codes. Always consult with a qualified electrician to ensure that the electrical system meets the requirements of the NEC and local codes.